Implicit differentiation, AP Calc 3.5 notes. Our first example we're going to look at is the equation of a circle, x squared plus y squared equals 25. And there's a problem here. I cannot find the derivative using normal solution methods of this function because it's not really a function. So because this isn't really a function, I mean, if I were to ask you what's the slope of the tangent line at -4, if I were to go to -4, I could have a positive tangent line here, positive sloping tangent line, or down here I have a negative sloping tangent line. So because this is not a function, I could have two slopes at the same x value that are different values. So this slope and this slope don't match. That's not good. You know, if I wanted, let's say like a negative 2x minus 8, or negative 1 point, I don't know, 1.2. So there's a tangent line. There's a tangent line approximately at -4. But I could also find a different tangent line at +4. And because I could have these two tangent lines, both at the same x value, not a function, not differentiable. So what do? In this case, what we're going to do is we're going to take the derivative implicitly. So we're going to take the derivative of each side. So we're going to take the derivative of x squared plus y squared equals the derivative of 25. So what is the derivative? Okay, if I try to take the derivative of the right side, that's not bad. That's just derivative of 25 is 0. The derivative of the left side is a little bit harder. I know the derivative of x squared is 2x. Here's what we have to do though. I have to take the derivative with respect to x of y squared. So what do we do in this situation? Because I'm taking the derivative with respect to x. I'm going to do what's kind of like a chain rule. I'm going to do the 2 times this stuff. It's almost like if we were to take the derivative of let's just say 2 stuff, or not 2 stuff, stuff squared. In that case, it would be 2 times the quantity stuff, but with our chain rule, we'd have to multiply by the derivative of stuff, whatever's that inside function. Same process, 2 times y, but because it's a different variable than x, I'm taking the derivative with respect to x, and it is not x. It's a different variable. We have to multiply this chain rule style times the derivative of y. So what we end up with here is 2x plus 2y times the derivative of y is 0. And we're going to treat this part almost like it's multiplication. So we're going to almost treat that as like a product. Well, what does that look like? We're going to have, if I subtract this 2x over, so let me minus 2x to this side, minus 2x to this side. What do we get? We get 2y times the derivative of y I didn't highlight that enough. This is our product. I apologize. Didn't highlight that enough. 2y times the derivative of y equals negative 2x. So now, if I want to solve for the derivative, excuse me, the derivative of y, I need to divide by 2y, and my final answer is going to be the derivative of y with respect to x is going to be negative 2x divided by negative 2y. So our derivative of y is going to be negative x over y. So our derivative of y with respect to x is the function negative x over y, or the expression negative x over y. So we've got our function here. What's another way to write this, though? If I don't want to write dy dx of y, I could also write that as y prime. So in the same way, I could write this as 2x plus 2y times y prime equals 0, and then this would be 2y times y prime equals negative 2x, and then if I divide by the 2y, I get y prime equals negative 2x equals negative 2x over 2y, or I could write that as y prime equals negative x over y. It means the same thing, right? This dy dx is just a different way of writing y prime. It's like when we did the ddx of f of x versus f prime of x. It's the same thing. So if I want to find the equation of the tangent to the circle at 3, 4, well, I've got this thing that I just derived. So I'm going to plug in my x and y. So y prime would equal negative x over y. But y is 4. X is 3, y is 4. So our slope of the tangent line is negative 3/4. And then we have to use our point and our slope to write our point slope. Y minus y1 equals our slope times x minus x1. And then we can simplify. We would get y equals negative 0.75x. This would be plus 2.5 plus 4 is plus 6.25. So this would be our equation of the tangent to the circle at 3, 4. Let's check that out. If I write y equals negative 0.75x plus 6.25, check it out. There's our tangent. Where does it touch? 3, 4. So there's our tangent at 3, 4. Okay, let's take some more derivatives. Implicit differentiation just means, if I can get back up here, if I want to take the implicit derivative, take the derivative of both sides. So I want to find the derivative with respect to x of x cubed plus y cubed, and that's going to equal the derivative of 6xy. All right, so what do we do here? We take the derivative of each part. and then the derivative of 6xy, it's a product rule, if you remember that. It's the first times the derivative of the second, which is just y prime, plus the second times the derivative of the first. Derivative of 6x is 6. So what do we get here? The derivative of x cubed is 3x squared. The derivative of y cubed, just like before, do the outer function, 3y squared. Now I have to take the derivative of the inner function, the y, just like our chain rule. So this is the chain rule showing up again. Derivative of the outer function is 3 times stuff squared. Derivative of y is just derivative of y, it's y prime. Then we get 6xy prime plus 6y. Alright, we're going to have to do some simplifying. We got to get our y prime terms together. So if I do a little bit of algebra, I'm going to end up with a 3y squared times y prime minus 6xy prime equals 6y minus 3x squared. That's if I do a little bit of manipulation to that equation. Alright, now I'm going to go up to the top right. I've got this stuff. So if I want to simplify that, I can divide out a y prime times 3y squared minus 6x, and then that's going to be equal to 6y minus 3x squared. And then my last step would be to divide. So y prime, if I divide both sides by this stuff, y prime would equal our 6y minus 3x squared divided by 3y squared minus 6x. And if I really, really wanted to, I could simplify by dividing a 3 out of all this stuff. I get y prime equals 2y minus x squared divided by y squared minus 2x. Same process as our first problem. If I want to find the tangent at 3, 3, plug in a 3. So y prime equals 2 times 3 minus 3 squared over 3 squared minus 2 times 3. Well, what do we get there? We get We get 6 minus 9 is negative 3. 9 minus 6 is 3. So our slope is going to be negative 1. All right, tangent. Same process. We've got a y minus y1 equals our slope times x minus x1. Or y equals negative 1x plus 6. So if I were to graph this, there's the Descartes folium, and what was it? Negative 1x plus 6. Y equals negative 1x plus 6. Check it out. There's our 0.33. There's the tangent to the curve. Okay. We didn't get much farther. We're going to continue with these notes tomorrow. We'll do some more implicit differentiation, and I will see you then.